So good evening, good afternoon, good morning, wherever in the world you are. Welcome to the 5G Accelerator Challenger Summit preview. This session is a preview for the actual event that's happening on the 21st of April, 2021. And today's idea is to show some, to give you a sense of what a 5G use case is, how is 5G currently being used, and so on. So we have a short session today that will involve people who are doing great work in 5G, and they'll share their thoughts about 5G. And then towards the end, we'll explain this 5G Accelerator Summit in more detail. And this session is one of many, some of which are on our YouTube channel, and we welcome the listeners around the world to check out other use cases that speakers from around the world have presented. So I'll share just to set the context for what this is about. Okay, so the 5G Use Case Accelerator Challenger Summit is an effort by the global 5G evolution to bring the best ideas from around the world into one place. Then they present to a panel of advisors. This panel of advisors are people who have experience working with 5G or doing research in 5G. And then we want the students to get feedback. So once students give us their use cases, they present, and then they're able to get feedback. Our goal with this is to really allow these ideas to become fruitful things in the real world. Okay? So right now I'll have 𝗘𝘃𝗽𝗍, who is the lead organizer for the Global 5G Evolution, the summit, and this whole initiative, to share a bit more about young leaders and how this actually connects to the young people and creating an innovative as well as a connected world for all of us. So, Ganesh.
Thank you, Christopher. Thank you so much. Dear students, welcome to the 5G Use Case Accelerator Challenges Summit 2021. Part of the reason why I care so deeply about the students group is because of the innovative values, not limiting to other values, such as to cultivate cultural exchange, universal human values, diversity, equity, inclusiveness, and creating a wonderful global society. This program is all about mobilizing people to action on the basis of shared values. This program is about create a new shared narrative of the common good in our polarized society. If there's one thing we can bank on, it's that young folks like you all are our best hope for a more sustainable world. All I wish to say is that there is a lot of pressure on the students, the young leaders, because you guys are going to have to save the world. And fortunately, I think you are all up to it. Now, the World Health Organization has long warned that ecological destruction, deforestation, and climate change increase the risk of pandemics. The COVID-19 crisis could possibly be a turning point in how government think about these ecological issues. Now that they see that there's such a price tag attached to this man-made ecological breakdown. So how to build the awareness of a sustainable world? Students like you can continually make this connection because people's memories are short. Whether we are facing on sustainability issues or climate change issues or pandemic healthcare issues. And I would begin today by creating those public awareness, creating education, the PR campaigns, drawing this connection between COVID disaster, natural disasters, and environmental degradation, and finding new and creative ways to communicate that into the public, and finding new and creative ways of innovation to solve those problems from these disasters. And this is the summit where your ideas can be showcased to a group of 5G experts worldwide. Now, we are in talks with a European venture builder a startup studio specialized on 5G technologies and use cases. And this venture builder already co-founded their first venture series A funded deep tech company, a private 5G network platform. And this venture builder is working on the ideas pipeline for building 5 more startups in the next 3 years. So we are on the same place looking for innovative ideas. And our approach is to identify ideas and co-build and co-found startups with the ideas owners. We'll further announce the detail on our website soon. And to all students, I always say to them, you have to be in it for the long haul. And you have to be a strategic in your courage, because we want you around for a long time doing what you're doing, which means thinking about innovation, not in weeks or months, but thinking this in years and decades. So my pledge to you is that to take this opportunity in submitting your innovative ideas. And I really hope we can continue build this network and family, and that we can continue to build it and grow it. And we are supporting each other for years to come. All right. Thank you.
All right. Thank you very much, Ganesh. So our keynote address today will be by Professor Ranjan Singh. Professor Ranjan Singh is with the Division of Physics and Applied Physics at Nanyang Technological University in Singapore. He's also done a lot of research in 5G, but now he does research in 6G as well, okay? So his keynote will touch more on the 6G part. So Prof, please.
Sure. Thank you, Christopher, for a nice introduction. Let me share my screen. Okay. Okay. Hello, everyone. First of all, I would like to thank the organizers for making this event happen, and for all the other people from different parts of the globe who's made it. I'm sure we are going to have a very nice discussion session here. So basically, I'm leading an effort on terahertz communication at NTU. This is a very enterprising building in NTU, very picturesque. And the building speciality is that it doesn't have many air conditioners. So the airflow has been engineered in a very smart way. And so a lot of people from NTU do flash the picture of this building. So we'll go straight to the point and talk about the different generations of mobile communication. So roughly speaking, every 10 years, we have a new generation. Right now, we are here looking at the onset of 5G communications. And if you look at this particular graph, what you will see is that there are 2 parameters that continuously changes when you move from one generation to the next generation. And those 2 parameters are the carrier frequency of the wave that carries the information and the peak data speeds. So the peak data speed targeted for 5G is about 10 gigabits per second, and the carrier frequencies are typically below 100 gigahertz. So it will be about 25 to 40 gigahertz or so. But our efforts are mainly focused more at 6G. So let's say about 7 to 8 years down the line, we'll be here and we'll be staring at using carrier frequencies of above 100 gigahertz. Now, the problem is that above 100 gigahertz, we don't have too many electronics that works. So far, the conventional RF or the microwave technology seems to give you all the scaling, and it's not that big a technological leap that you have to think about. But when you have to go to 6G, you really have to think about devices above 100 gigahertz, which are extremely rare and very, very lossy. And terahertz, the advantage will be the large bandwidth, extremely low latency. Now, where is terahertz? Terahertz, if you look at the electromagnetic spectrum, it sits right in between the microwaves and infrared. Terahertz is also known as the final frontier of RF. And I think most of us here know that. Now, when you have all this um, computation that's happening on cloud, a lot of data is being generated. Just excuse me. ฤति, can you shut down the TV? Shut down the TV. Sorry for the background. Um, so the whole idea here is that a lot of data is going to be generated on cloud, and we aim to process that real time using all this AI algorithms. Now, all of the data movement has to happen through extremely high-speed links, and these high-speed links will be provided by this terahertz technology or above 100 gigahertz technology that would affect almost all spheres of life. And a lot of computation will happen on the cloud itself. So we call this project as Terracom, and terahertz has its own challenges in terms of attenuation or in terms of distances over which you can send information. So for now, we are targeting only medium range application, which means about 10 to 100 meters. Here is a small example of, let's say, establishing a terabit per second link between, let's say, flash drive here and a user here. So it's a close distance or medium range distance, but even establishing such high speed links will find a lot of utility in personal network use cases or also in wireless data centers. And the technology that we are using is based on, on physics of topological insulators. I don't want to go deep into this, but what I want to tell you is that this is a pretty cool technology that won Nobel Prize in 2016 for electrons that propagates without any scattering, and it propagates through these quantum states that are highlighted by these sharp linear dispersion lines. Now we take that concept and bring it into photonics, where here you can see that in this particular device, the photons can go around the sharp corners, and there's no loss around these corners as you couple the wave in and couple the wave out. Now such bends are extremely critical for multiplexing on chip or transporting signal on chip kind of applications. And that's what we are targeting to do. So we are building terahertz transceivers basically for 6G and all with silicon platform, or look at also some heterogeneous integration. And the ultimate goal really is to be able to achieve 50 gigabits per second of data rates over distances of about 10 meters with extremely low bit error rates. These are some other conventional technologies that people use for transporting these terahertz waves, and we feel that this topological platform that can somehow support the loss-free propagation of these waves is something that overcomes all of the limitation posed by these traditional platforms. And here is just an example of the device itself. This is our real device, and you can see that this device has a lot of bends. It's a high resistivity silicon chip where you couple the signal in on one side and then couple the signal out. Here is the interface with bends, and this is the interface that we call as the topological interface. You can see that when you compare signal transmission through a straight waveguide and a waveguide with 10 bands, the transmission is extremely high for both the cases. Whereas no interface means it does not have any topological physics involved, and therefore the signal can be very noisy. And this is again a loss analysis, and you can see that in this particular case, the signal is extremely lossy, where you use a traditional photonic crystal and not a topological platform. So we published this work in Nature Photonics very recently. So I would like to share with you this video demonstration of how you use this chip for sending video or for encoding the terahertz waves with the video itself. And then, oh, I'm not able to play this. Let me, where is it? Yeah, so you can see that in the background you have a 4,000 pixel ultra high definition video through which we are sending data at 6 gigabits per second. Here is the device, and when you outcouple the device, the video in the background disappears, and when you couple it back in, the video will reappear. Okay, so this is for a wired case, just a transmission over chip. Here is another example of the same device, but being able to work in a wireless mode. So you see that the device is here. There's no connection here, so that's why this is a wireless link. And we bring in a paper. Terahertz is transparent to paper, so nothing happens in the background. But when you bring in a metallic sheet, it will basically block the wave, and therefore the video disappears. Once you remove it, the video will reappear.
Excuse me, Prof. I couldn't able to see the video.
Oh, you're not able to see the video?
Yeah, I can see the video though. Maybe your connection connects.
All right, sure.
Okay.
Thanks.
Yeah. So pretty much this is the demonstration I had, and what we are trying to build at NTU is a terahertz 6G chip with the sources on top of that chip, and terahertz antennas and phase shifters, so that we can have all types of beamforming strategies on the chip, and basically to be able to build a terahertz 6G transceiver. Yeah, I just would like to acknowledge all my collaborators, students and postdocs, mainly from NTU, and this work was carried out in collaboration with Osaka University. Thank you very much for your attention.
Thank you very much, Prof, for that excellent presentation on 6G. And the idea for students who will be watching this is that someone with the knowledge of Prof will be able to give you some feedback on what you're doing. And that's why we're actually doing this session, to show you the people who are likely to look at your work and therefore provide you very good feedback. You know, that is hard to come by. So thank you, Prof, for that.
Sure, thank you.
All right, coming up next is 𝗬𝗪cie𝗍𝗪𝗂𝗪. He's a doctoral student, a research assistant at Oulu, North 𝗬𝗪cie in Finland. Okay, and he's going to talk about 5G massive machine type communication for next generation wireless communications. So Tushan, please.
Yeah, hello. So I'll share the screen.
Yes, please.
Right, you can see the full screen, right?
Yes, good. That's
okay. Yeah. Hello, I'm 𝗬𝗪cie 𝗍𝗪𝗂𝗪, doctoral student at CWC, University of Oulu. Actually, in these presentations, I like to cover massive machine type communication plus critical machine type communication towards 5G and something like 6G as well. So yeah, as an introduction, so everyone knows in the next human life, we mostly targets for digitalization and data-driven society. So in the 5G new targets kind of connect with ultra reliable low latency communication plus massive 𝗬𝗪cie kind of 2 of 3 main service classes. So in that perspective, MTC is one of the key technology to satisfy most of the demands of humanity. So in these presentations, I mostly plan to consider about what are the drivers and use cases plus requirements and service classes. These four categories mostly targets for 6G as well. It's kind of beyond 5G targets. So first, according to Frost and Sylvian's Visionary Innovation Group, they named 13 mega trends. Like this looks very interesting too. That's why I've gone through this slide, this site actually. So they kind of initiate like these are the areas will be more kind of trend in future around 2030 target. So like first one is a connectivity and convergence, another one is a cognitive era, and smart is the new green. Another one is bricks and clicks, new business models, urbanization, city as a new consumer, social trends, health and wellness, economic trends, innovation to zero, future of mobility and future of infrastructure and future of energy. So from these 13, the white paper published by my university about the critical and massive machine type communication towards 6G. Actually, this published in last year. So it categorized 6 most important key drivers out of these. So from that perspective, they consider autonomous mobility. So in the mobility, mostly consider from level 3 to level 4 or level 5 of autonomous connectivity, and a lot of devices, a lot of machines will be, and sensors will play a role. Another one is a connected living. So nowadays everyone's work from home, so we need a connections everywhere. So it's mostly target for that global connectivity, like everyone's have the connectivity in the entire world. Another one is factories of the future. So from industry 4.0 to we need a requirement for industry 5.0 as well. So from that perspective, how MTC will play. And another thing is a digital reality as a front-end technology. So in this one, like augmented realities and like evolve from the basics to how it kind of comes in the mobile device. To that point will be a main role. And another one is towards a zero world. So in that concept, like everyone's need a battery life and the green growth, and for a long lasting battery kind of capacity, something like that. So those comes under towards zero world. Another one is a data as a new oil. So in this one, it's like transferring data for like feasible applications, like that one will be connected to all above mentioned technologies as well, like autonomous mobility or the connected living, how the data transfers in a high sensitive manner. So from the drivers, the use cases are like in detail can say about in the connected living, like industry 4.0 kind of converge advanced manufacturing technologies with data driven. So in that one, AI also going to play a big role about how industry with artificial intelligence plus machine learning will play together. At the same time, the design of industry 5.0 with lot of sensors and the sensors identification, detections, and the performance evaluations. Like there are a lot of stuffs connected with the real implementations comes under the connected industries. And another one is the SWAN network. So this is kind of interesting one because when there are a lot of autonomous vehicles, for example, self-driving cars and autonomous guided vehicles, AGV and UAVs. So most of the time we consider in a 5G, it's kind of separate network. So in the future, there's a requirement to consider in a kind of group-based scenario, like as a SWAN network. So the network going to kind of play a big role in the industry and then for human life as well. Like, for example, during the pandemic and all, we all need a real requirement to machines to survive. So in that sense, these swarm network definitely have a big role. At the same time, personalized body area networks, actually in the current generations, mostly we all have smartwatches and earbuds. So within short period, you all know the earbuds and smartwatches comes to a big role. So in future, this may be like a future clothing. So the clothing systems may have some devices which satisfy the requirement of the particular person, something like that. So maybe a skin patches or bio implants. So in that perspective, machine type communication sensors plus like biological perspective also needed. So from those going to be the next possible application scenarios for personalized body area network. At the same time, zero energy IoT, because in that one everyone's really knows, even for a smartphone nowadays, it's a very big role how much energy consumptions. So the advertising feature also our battery lives like this much of days and all. So when there are low power devices and sensors will come in the MTC, so the power will be one of the main target areas. So in that one, like zero energy or like energy harvesting, wireless energy transfer will be one of the main kind of area to cover those requirements and satisfy the machine type devices needs and all. Another one is the Internet of Sense. So in that one, human sensors to interact with machines, like enabling our sense to a perspective with the internet machines, plus we are receiving the feedbacks, and based on the feedbacks, the decision made by the machines and the human is kind of connected with the machines and human sensors. This in nowadays this maybe looks more like imaginary, but that those requirements will be there in coming up years. So ultra reliable and ultra broadband and ultra response near real time applications will be needed. So in when it's connected with the sensors plus human, there will be a reliable requirements, and how much the devices response according to the sense will be a critical role as well. And smart contracts, so this is distributed leader technologies, you know about that. So for example, like I can say the autonomous driving and the vehicles may have, they are in the network. So when the two vehicles meet together, so the one vehicle can request the informations about the path or the other roads that the another vehicle have. So in a smart way, those information transfer to the another vehicle. So the communication between two machines can be done in an efficient way, and the implementation will be a very, very promising. So these can possible use cases actually, and future requirements. So from this one, these requirements, it's kind of briefly I mentioned like how dependability and, for example, the reliability 10 to the power -9 and 0.1 millisecond latency. So these are kind of the decisions like expectations, something like that. So efficiency in the sense like energy efficiency, how much, and how the cost will be there, because when the lot of devices and machine type devices are connected together, so definitely a cost will be play a big role. So low cost, low power devices going to be the massive machine type devices. And scalability, as I said earlier, so global connectivity is one of the mandatory tasks at the moment. So massive scalable to connect all over the places to give like for example, like everyone have the, make sure they have the internet connections and all. So plus there will be a 3D connectivity requirements also will be considered for the scalability targets. And the sensing like localization, accuracy, and positioning will be play a role in the sensing area. At the same time, like in the throughput, the spectral efficiency, because we have the particular bandwidth. So how much we can achieve on top of that will be the throughput target as well. And beyond that, all security, privacy, and trust, those are kind of most of the important stuff nowadays people considering, like how much the privacy and the security goes definitely in the next generation. So when a lot of devices and massive machine type devices comes, so definitely how the low cost authentication and authorizations at the same time acceptable, reliable also going to play a role. So with the requirements, the service class will be categorized maybe like in this way. So maybe this is the opinion, maybe dependable critical MTC, like extreme, ultra reliable, and low latency, along with other measurable dependability, like other devices will be in the dependable critical MTC. And another one is a broadband critical MTC, so supporting mobile broadband at the same time with high reliable and low latency. So when there's a critical MTC, definitely the reliable requirements will play a big role, how much we can really achieve about that. And scalable critical MTC supporting massive connectivity with high reliable and low latency. Those first three mostly consider about the critical MTC. So those three considering high reliable as one of the main requirement as well. Another fourth one is a globally scalable massive MTC. So supporting ultra wide network coverage throughout all the space dimensions, including volumetric density of devices. So as I said earlier, the 3D connectivity and the requirements of globally scalable MTC as well. And the last one is a zero energy MTC. So massive deployment of radios, especially for long battery life and networks lifetimes will play in zero energy MTC. So these are the service classes. So actually the informations are based on the two references about the white paper and the 60 kind of the summit paper. So if you are interested, you can go through these papers as well. So this is about the kind of basic description about MTC. Yeah, thank you.
Sushant, thank you so much for that presentation. And now we will go on to our next speaker, who is 𝗬𝗪𝗧. 𝗬𝗪𝗧 is a consulting director for BT Consulting based out of London, the United Kingdom, and he will share with us about a typical 5G use case. So White.
Great, thank you. Can you hear me? Can you hear me okay?
Yes, yes, we can hear you.
Lovely. So let me try and share my screen. So is that full sized? Can you see it?
Yes, yes.
Perfect. Okay, great. Thanks for getting the opportunity to talk. So great to be involved with university students. I was a university student a long time ago. And so I just wanted to kind of bridge that gap for me between academic and the real world. So during the day I work for BT, we're doing a lot of work around 5G. I thought I would talk about one particular use case around smart airports. And I wanted to encourage all of the students to use their imagination, because we need more imagination with 5G. This is one area I think and believe there are opportunities, and I've discussed this in my consulting career with other consultants around the potential. So I just want to kind of spend a couple of minutes, 10 minutes or so, just talking through why there is a business opportunity and how 5G can enable opportunities in this space. So we all know there's been a pandemic. Airports were experiencing huge growth in passenger and air freight volumes before the pandemic. But there is a real reason for airports to use digital technology to drive efficiencies, to increase security, and to essentially improve the passenger experience. And if you can improve the passenger experience, you can then drive more value and more business for businesses that are in the airport and the airport industry as a whole. And I'll talk a bit around some of the airports, global airports that we have today have acknowledged the importance and opportunities of digitization. And maybe even the pandemic will accelerate that because of some of the aspects of traveling now that we've got to consider that we didn't consider before. So So this is an area that has typically been served by wireless, but just for the consumer. But I believe there's much more in terms of the B2B aspect for 5G that we need to look at. But why airports? As a good consultant, we always need to think of the why in the business case. Some of these figures speak for themselves. You know, you've got 58 million people employed in the air transport industry alone. How are they served? You've got 8.3 billion passengers transported as well. How do you make that experience better for them? You know, the figures that the airport industry and aviation contributes to global GDP is eye-watering at 2.7 trillion before the pandemic, agreed, but it will rebound over a number of years and it will get back. And you've got 118 million tons of cargo transported. So all of these figures from a global industry perspective point to me that there's a real opportunity for 5G to provide a more digitized experience, a more smarter airport. And essentially, it provides an opportunity. And I'll talk about some of the vendors who've recognized that and who are actually targeting airports as a way forward. So just to try and make it real as well, what could 5G do in airports? So airports have growing data needs. The diagram just shows you some of, a few couple of ideas of where there's increasing amounts of data. And there was a comment made before in the presentation about data being the new oil. You have so much oil in an airport, it's incredible. So let's look at, things like uploading engine data. This is already done by the likes of Rolls-Royce. They actually have a business model of selling thrust by the minute, or not planes, but actually the service. So that engine data needs to get into an AI platform, into big data lakes, and be processed to be able to do preventative maintenance, to know when you need to service a plane before the plane even knows it. So there's huge amounts of data there that can be served by 5G. You've got the ground flight and crew access using smart tablets, being able to be, doing their jobs more efficiently, could be served better by 5G. Entertainment systems on the airplane today, probably using proprietary technologies. Again, another opportunity for 5G. Interactive maintenance, updating aircraft logs. And this is just in terms of, let's say, airside in an airport. You've also got the passenger side as well, and all the opportunities there. So airports have growing data needs. 5G has an opportunity to capture that, but it needs to be focused on solutions that offer value and offer more than what's there today, because these things are being served today by existing technologies. And one criticism could be, Leo, this is all served today. Yes, it is all served today, but there's a great opportunity for 5G to provide a better, more efficient service and solution for all of this data that gives a holistic view and gives value to airport operators and the businesses and the aircraft carriers as well, and the staff within airports as well. So that's the kind of call to action and the idea around this smart case. It could well be that 5G's arrival is well timed for global aviation. And there's two aspects of when we look at problems as consultants, we try and boil it down to a minimum number of aspects that are easy to understand. One, it could be about enhancing existing applications, so enhancing passenger processing, baggage management, airport operations. Those are things there today. So 5G could enhance those things, but also 5G could enable new technologies as well. Edge computing in an airport, the Internet of Things. We just had a discussion about the potential of Internet of Things, digital twin creation, artificial intelligence. All of these things will come into the airport, over the next decades. Back to Kenish's view of inspiring the decades, and 5G can provide a platform for that. And a comment from 𝗬𝗃. 𝗬𝗃 is the industry body that looks after the aviation industry, and they acknowledge that 5G can be used for speed and data density to enable better monitoring analysis of assets in and around the airport. You also have the likes of Ferrovial, a big Spanish infrastructure group that own airports, also looking at the potential for 5G as well. So I wanted people to take away two things, students to take away two things from this. As a consultant, you try and boil things down to really understandable aspects. One, 5G can enhance existing applications, and secondly, 5G can enable new technologies as well. So I mentioned about 5G could be coming at a great time for the industry, and it's not a great time if we look at it from a global perspective with the pandemic. But we are now going to have to think about in the COVID era having more touchless journeys. And I don't know if any of the people here have recently taken a flight anywhere. That experience has changed from what it was 2 years ago, and 5G can help in terms of making the airport more smarter. So now we need to be looking at social distance measurement and managing that better. Airports, I'm sure, have some capabilities there today, but 5G could help around digital cameras and sensors, being able to monitor distances between passengers and staff. And these are the real use cases here and ideas that could be fueled by 5G or other technologies, but I feel there's an opportunity here for 5G. Health check screening. So, you know, checking the health of passengers and the temperature of passengers before they board is an early indication of whether they might be carrying the virus or not. So health check screening could be supported by 5G. And then we're going to have to get used to a world of more touchless passenger boarding. So secure wireless networks supporting airports biometric system processing and using 5G to sort of support that. So these are just a few of the use cases that have been accelerated by the pandemic that actually may provide an opportunity now for 5G. And you'll see, if you look at what some of the infrastructure vendors are doing, they are offering solutions tailored to these areas because there's demand, because the airport industry needs to recover. It will recover, but it's going to recover in a different way until we have the vaccine distributed globally across every country. We still need to make these checks. So these 3 use cases give an idea of potential areas for 5G to support the new COVID era where we're going to need touchless journeys. And this final sort of diagram, I hope you can see it, just shows you Nokia's architecture that they have from Bell Labs, which is their research division around the airport, and they see opportunity around high performance networking, around multi-cloud, around digital value platforms, and also business applications, and the whole fabric that will wrap around an airport. And so 5G could be part of that, be it wireless or wired. And I think we'll go more to a wireless society. I'm seeing it in the projects that we do at BT Consulting. You know, there's a big recognition from enterprises that the world will become more wireless, and that plays into 5G, plays into 6G as well. But yeah, we're going to have this high performance networking, massive broadband wireless networks connecting things, people, and that can all be stitched together by 5G. You're going to have cloud, you're going to have local edge cloud, distributed edge cloud, hybrid cloud to take that data from devices, push it into compute and workloads that can then do the clever analytics and artificial intelligence to drive value from that data in the airport. And then the platforms, you're going to see platforms, and it'd be interesting to see, will airports open up that platform, because they'll have a lot of rich data on, for example, the demographic of people that are in an airport, the kind of things they like to do, and that could be useful for the businesses in an airport, how they can enable more value, and then for also the crew and also the aircraft operators themselves. So there's lots of platforms that could be offered to different people, and then there's the business applications as well. We spoke about passenger experience, spoke about the COVID era touchless experience we've got now. And there's many other business applications, and all of that needs to be wrapped around security, of course, very important. So that having that zero trust, if you want to use a good framework, zero trust capability around wrapping that whole secure environment so that the airport is secure, because airports do need to be secure. They're part of critical national infrastructure, and 5G will only play a part if it can provide and ensure that security is there. And so I just wanted to give a message that the infrastructure vendors are ready for 5G. Airports are recognizing the potential for 5G. The opportunity is there. So I just wanted to give that as a view of a use case to students, just to whet your appetite. Use your imagination, please. We need that imagination in the industry to drive, new thinking. And I hope that has been useful. That's it for me.
All right. Thank you very much, Leo. And that's what we are intending to have students do. So we have Leo here present about smart airport, for example. You would present something even more specific, right? You would tell us about a specific way in which 5G can be used, and then we'll have feedback, of course, from these experts, right? So all the presentations, and as well as something we'll show later on, are about slightly more general, right? More general views of use cases. And what we're asking of you students and startups around the world is you give us something very specific, something that can now go on and be rolled out into the world right away, right? So thank you for that. And coming up next is Christian Masson. Christian Masson is talking to us from Aachen, I believe, from Germany, and he's going to talk about 5G for next level industries. Christian?
Yes, thank you very much for the kind introduction and giving us the opportunity to enlighten you, giving you some insights of the 5G activities we do at RWTH Aachen University Campus. Since that's a site of new innovation where we bring basically the industry leaders in technology together with renowned research institutes of our university to come up with new ideas and to foster the next products and developments you can see. And we brought along some examples from a manufacturing side. So let's dive right into. What are we going to talk about? When we talk about 5G for next level industries, maybe it might be good to know what next level industries are before we're giving you an idea about how, from our point of view, 5G is changing the playing field, and that it's actually an ecosystem we're talking about, which will change how we use it in production, in operations itself. So where does it start when we talk about next level industries? We heard it before that data is the new oil. I couldn't agree more to that, because data and basically the efficient use of data will change how we do business completely. We see it already with all the AI applications coming up, it will just increase. And it always starts in the same pattern. We also follow with our use cases. You start with visibility, having the opportunity to observe the assets, their conditions, the processes, also the locations of everything. That's the base. You need to connect so that you can actually run all the other stages. With transparency, you can have rule-based processes. You can run pattern recognition. When you go one step further, you go even into the predictive part, not only in maintenance, in logistics, in production itself, run the simulations with the real-time data, always confirming, affirming what you're doing. And then you come there where we truly would talk about next level industries, or in Germany, we usually refer to as Industry 4.0, that you really have flexible, adaptive processes, adaptive companies and supply chains, which can react quite flexibly to the daily challenges we have on a global, on a regional, on a national scale they're constantly facing. So what's what they're up to? And here just an example, how does that look like? You have your connected devices on one side, you have your production sites, then you have to aggregate all the data you get from these. You have to bring in the logic from the business applications you're running, the ERP systems, and so on. And best of all, for all the deciders out there, for the people working on the shop floor, you would provide them with just the right information, with just the right decision to make based on all the data coming in, all the data flux in a handy to use app you can use basically everywhere. And this is something we have to deal with on a daily scale on the ecosystem, basically. You have your devices on the shop floor, sensor systems, products, whatever. In between, with a material flow, you have your transport systems, your forklifts. Everything needs to provide the data of position of the actual state. You have to aggregate it somehow, and as mentioned before, somehow connected to the actual production processes, to the orders. It has to be delivered. And these are the challenges these next level industries are facing, always having, as we call it, a digital shadow of everything what's going on, and is indicated here with the green check marks. Is everything in order, or do I have to zoom in to fix something? And always being able to monitor and make decisions on what is wrong at the moment or what can be optimized and fixed. So when we talk about 5G. How can that change the playing field in that regard? As we see it, first of all, I mentioned before, we have to make the physical objects kind of smarter so that they can interact, that then can connect with each other and with the rest of the world, basically. So for us, connectivity, and especially 5G as a backbone in that regard, a quite powerful one, is basically the glue, sticking all the other technologies we need together. Everything we think about in terms of sensor systems, being able to actually sense the environment and what's going on. How does it connect to the rest of the IT systems we have with the interfaces? How do I provide basically a platform for interaction with a human workforce still? How's data processed and analyzed, even in big volumes as they are coming in? Do I need new interfaces like AR, VR to provide that? Of course, always having data security in mind and maybe even automating it, bringing it to direct application on a shop floor or a logistics center, regardless. So also just to bring it to mind, we heard it from the colleagues before, the 5G key features are defining basically the whole solution space of possible use cases with the bandwidths in the range of 10 to 20 gigabits per second. You are able to process a lot amount of data. And with ultra reliable low latency cases with down to 1 milliseconds already with 5G, not talking 6G even yet. We will be able to have all these autonomous systems, remote systems and operations, high bandwidth, low latency. So really being able to have remote experts working on a site as if, even virtually as if they were there themselves. And as we also learned before, there will be a great opportunity when we connect basically everything as a huge Internet of Things approach in industry. Being able to connect so many more devices for logistics, basically every crate, every container, maybe every product you ship can be monitored. It's changing a lot in that regard. And here we're just giving you a few examples from a selected cases in Aachen. We work together on with the partners in industry, with our colleagues also from RWTH Aachen University, especially the IT center. And here you see just a measurement, a sensor system with full HD camera stack stuck on an automated guided vehicle in that case. And this is now not a motion picture, but you can see the data latency you receive as a throughput time. On the left side, you have constant latency over time. When we set it to a certain parameter, you can rely on that. And on the other side, you have a Wi-Fi signal. Even see the loading bar there on top in the picture from this still stand. But also the high variance you have. And in a few cases, and when we really talk about real time in these scenarios, up to 1 milliseconds of a delay might be basically a game stopper or changing the game if you can reliably provide it with LTE and now the 5G in that regard. So here we just brought you an example how it works together. You see on the right side an AGV approaching, and one of our workers in the shop floor, one of the colleagues stepping from around the corner, which the AGV, even with the high equipped sensor systems it has, can't see. But you see a yellow sensor system there installed. And in real time, they will be able over the 5G network and connected edge processing to assess the situation and if there's a danger or not. Since he did that, you saw how fast it was computed and it stopped before any collision or anything could occur. In that regard, we're really talking about the milliseconds you can achieve. And I think it's also crystal clear that it has to be ultra reliable in order to work, because we're talking about worker safety here. in a productive environment. So that's introduction, but maybe also looking further, what could you do when you have such a high performance network and, as mentioned, always connected with the sensor systems to a data processing unit on the edge, usually so-called fog computing from some. What could you provide? As you can see here, when the automated guided vehicle, you see running on the bottom right, is going for the factory on its way of transporting goods, transporting crates. It can recognize also in real time what it sees. So it can spot inventory, which was maybe misplaced in some place in the factory, in the logistics center, which basically happens all the time, and can identify them. And the next step we're working on, it can identify exactly what order ID it had, so that you never lose anything in the factory anymore, and you do it while already transporting the things. So you can create additional value, which is still increased by what you see on the top right screen we just put here together, because what you could do with 5G, for example, as well, is provide localization, the position of your assets which are connected. True, that's still at the beginning of the new releases of 5G, but it promises accuracies of 3 meters and maybe later below, with which you can run a lot of use cases, uses as triggers for a lot of different business processes. And that's where we see it. Always keep in mind, 5G is an ecosystem, and it basically connects all the other possibilities you have when we're talking about artificial intelligence and big data. Only comes true when we have connected devices on the shop floor, which can perform also what we calculate and sense with high bandwidth how the environment looks like here with 3D scanning data in real time, and also video camera signals, which then can be analyzed and evaluated. So also I would encourage you to get started, to get cracking with what's possible with 5G. And to sum it up, we can clearly say from Aachen perspective, that's not rocket science anymore. And also encourage you to think big when you think about the ideas and the visions, and just divide it into small steps how to reach them. You can start very soon, get connected with experts, with colleagues to create more ideas and work on that vision. And then you can always scale it fast and turn it into reality. Thank you very much.
All right, thank you very much, Christian. That's another good example of showing a specific case on the factory floor, in a specific case of identifying things. And so as you can see, listeners, you will obviously need to interact with other parts of the technology landscape, right? You collect the data, but you need sensors. You collect the data, you need to get intelligence out of it, you need machine learning folks and so on, right? So we're encouraging people, not just people who are doing directly 5G research or doing studies in 5G, but you can collaborate with others across other fields, because ultimately the solutions will need you to look across other fields as well. So thank you, Christian, for that presentation on how you can use 5G, but leveraging other technologies as well. Okay, so for the next 5 to 10 minutes, I just want to open the floor to the people who are here. You can ask questions to one another, because I realize we're all in 5G, but we do slightly different things. And it'll be interesting to see what we can learn from one another in this 5 to 10 minutes. So I'd like to just open it up to whoever has questions for anyone in the group, and then I'll close it off with a short presentation on my own. So, yeah, anyone can really go ahead and just ask.
Maybe just starting, if I may, because I was very interested already in the first presentation by Professor Seng. As we learned about 6G, we are working over 5G, and that's already a game changer for industry and something completely new. When do you expect 6G to really hit also industrial use from your point of view?
Yeah, that's a great question, Christian. Thanks for asking that question. So, okay, just by looking at the white papers from some of the top players like Samsung, Huawei, Docomo, 6G, some of the 6G products will hit market by 2028, 2029. So, but then most of these players, they have started research on 6G, and the new entrant to this game is Apple. I don't know if you heard about it, but Apple is betting big time on terahertz based 6G communications. So yeah, 10 years from now, for sure.
Okay, thank you very much. And I'm not sure if I can ask just another question to Mr. White. The case we heard about airports. What we also hear from our partners we have in the network is always about you have wireless communication. Is it safe? Is it reliable? Is it the same you also get as a question from your clients, from your partners? Do they start to trust in it?
That would be for Leo White, right?
Yes.
Unfortunately, I think he's not still in the room. I think he left the room. So we could pass that question on to him, but he's not presently available to answer it. But if anyone has thoughts, sure, you can share thoughts. Even the audience members, if you have thoughts, you're welcome to share your thoughts on these questions or to ask questions as well. Okay.
So maybe I can ask a question to
Yes,
Christian.
please.
So Christian, who is supporting the 5G infrastructure in Germany and in Europe? I mean, across the Europe. So is it Huawei-based products or some other companies are in the fray?
You basically see the major players. We all know the three global players: Ericsson, Nokia, Huawei. You will see with operators in their networks. Also going into this private network games where they can run their own networks on site or in combination, as we see with our partners, for example, 𝗘𝘃𝗍 Telekom, that they run the campus networks where you can have both of two worlds. But what's interesting with the Open RAN discussion, so the rather open architecture approach to the networks, you see more players coming in and also starting the efforts in Europe, also in terms of industry applications. But that's at the beginning, I would say.
I see. Thank you, Christian.
So I just want to follow up on that. In general, I'm wondering, Open RAN would then, Open RAN and just open source hardware and software in general, that would allow just about anybody then to create 5G modems, or what does open hardware, open software mean for the world? I mean, because right now I'm assuming the big guys who actually create the radios are the likes of Huawei and Nokia and others like that. But when they introduce this open philosophy, does it change who makes the hardware? Or what exactly does Open RAN introduce that would be an innovation in a sense? This question is for anybody who has knowledge on Open RAN or open architectures.
Maybe just to make a start, it basically changes everything you mentioned. It allows for new hardware vendors to bring in maybe just a component, just a module of the overall network architecture, maybe just an antenna, maybe just the core server for the network. So it's really modular in the end, and you can have different vendors in comparison to just one, as you see it nowadays in the networks we are calling on or we are connected to right now.
I see. Thank you.
Yeah.
Maybe
I would like to add one point, Raj, here.
I would like to.
Raj, you
Yeah,
go ahead.
Yeah, in the Open RAN system, the central unit and the baseband unit will be supplied by another vendor other than the radio unit and the core unit. Let's say Ericsson has supplied the whole system. Earlier, Ericsson has supplied the whole system. In this Open RAN system, other vendor like Mavenir, Parallel Wireless, AltoStar, or Intel, or even Microsoft or HP can come back with a small box with baseband unit, distribution unit, and central unit, and plug in between the core network and the radio unit of an operator. That is a kind of Open RAN architecture. So operator has a choice to buy the equipment from other vendors like Mavenir, AltoStar, Parallel Wireless, or Intel, so that the network deployment costs will come down. That is another advantage. Okay. Because the number of RAN nodes are more as compared to the core. Let's say core nodes are 10 in United States. Let's say core network has 10 units or 15, 20 units in the United States, whereas RAN units or radio base stations will be in thousands, maybe 20,000, maybe 50,000 across United States. So if you replace Ericsson with the Open RAN systems, the cost of a network deployment will come down.
Thank you, Raj. So yeah, for the people submitting the 5G use case, the good news is that it's going to be easier to deploy 5G networks, so your solutions will be easier to implement overall, I believe. So, 𝗃𝗃, did you have something to add as well? Or
I think more or less Raj have already answered what I wanted to say.
Okay.
Thanks, Raj, for the explanation. I appreciate that.
You're welcome, sir.
Right. Thanks, everybody. So I'll just do a quick overview of the 5G Accelerator Summit itself, and this would be the end of it, right? So this is for people watching so that they have a better idea of what this whole summit is about. So I'll share my screen. Okay, so you have heard a lot of speakers talk about what 5G is and what 5G enables, what is it likely to enable. But we know that we don't know the full scope of the things that we can do with the new network, right? We did know before we had 4G, the things that 4G would be able to do. But what we're doing with this initiative is we're encouraging people to start thinking about the different ways that 5G can be used, right? So we're asking people from around the world to submit for this Accelerator Summit as use case, okay? And it's happening on the 20th of April, 2021. So essentially we want you to just be creative about what would be possible if we have a much more robust network, we have a much faster network, we have a low latency network, what would be enabled, right? And you submit that use case for free before the 1st of April. And then once you have submitted, we're going to connect you with, so first of all, once you submit, we select a few people because we will have 8 people present to a panel of advisors, okay? And the kinds of advisors that you will be working with, or the kind of advisors you will have on the day, are the ones you've seen here today, right? People who know their stuff, people who have done research, people who have implemented real projects in the real world. So they will give you feedback that is very hard to come by, that you would potentially have to pay for to get that kind of feedback. And we're hoping that you can get that. We're hoping that the use cases can get that sort of feedback so that they're refined, okay? So the use cases can be, broad, so long as they include 5G, right? They could be about the environment, about health, about the social issues that we're encountering as humanity. And then we at Global 5G Evolution, we connect you with a network of people around the world with expertise in this area. And to drill down the actual day, on the actual day, we'll have about 8 groups of people presenting from 4 to 5:20 p.m. Singapore time. That's GMT or UTC plus 8. And those best 8 teams will be selected from the submissions that you make on our website, which I'll show a bit later, okay? And we have a template to guide you how to write out your use case. I will again show that later in this presentation. Any student anywhere in the world, any startup anywhere in the world, you can submit your idea. You don't pay for it. We connect you with the people, and if your idea is good, then you could actually go ahead. That's what we're actually intending to do, not just you could. That's what we're going to do. Once you submit your idea is good, the feedback that you have gotten from advisors is incorporated, then we will connect you with other partners to help you bring that idea to life. So you're not just presenting and then it ends there. Our goal is to make sure that that idea becomes a real solution in the world. And so we have sent out these invitations to universities around the world. So you'll be interacting with, as well as if you think in terms of competition, not really the way we think about it, but you can think of it as there are all these other folks around the world who are involved, right? We're also presenting their 5G use cases. And all you have to do is just submit it to global5gevolution.com, okay? And to get you all excited, there are prizes. So once you have made your submission, we look at it, we invite 8 of you to make a presentation to the advisors. Out of those 8, 3 of them will get these prizes. You get $1,000 US, the top team. The team can be 1 person, can be 2 people, or can be 3 people, right? We like collaboration, so it's up to you whether you want to have it within your school or within your country or even across the globe. So it could be someone in the UK connecting with someone in Senegal or wherever, and you come together, create your use case and submit it to us. And if you are in the top 3, these are the prizes for you. Now, the presenters today, as well as if you look at our other YouTube videos, you will see have talked about many use cases, okay? Today we had someone talk about smart airport. There was a little reference to smart factory as well. But these are the general themes that these technologies allow, right? Now, what we want you to do is to look at these as starting points, as areas that you could start from, right? So if you are thinking about smart transport, then you would submit a use case that goes into detail as to one particular way of implementing smart transport application, right? That's based off of 5G. So we have these on the website to show you that these are the major themes, but then you choose one theme that you want to focus on. This is a continuation of these. There is a great variety of themes. This list is not exhaustive, but we're hoping that this sort of gets you to think about the many potential starting points for a 5G application, 5G enabled application or solution. And for companies and individuals out there, as an initiative, we're doing this nonprofit. Our goal is to get the best ideas from around the world, get them connected to and with people who have knowledge on how to make them better. So we would love to have people who would love to have people sponsor this initiative, right, to make it sustainable. And we will use whatever tools we have to get your brand out as well. So the students around the world will know about your company, and also we'll have it on our YouTube channel, right, for keeps. For students, you can, of course, apply with your use case. That's what we would love for you to do. But you can also come in as a volunteer. As a volunteer, you're working with us behind the scenes to connect with the advisors, to connect with potential participants. You learn skills that are can be applied in other areas. In other words, for you to advertise for this event, you need to learn, how to use Facebook, Instagram, and others from a marketing point of view. Okay, so we're hoping these skills can be useful to you beyond just Global 5G Evolution. But you can come in as a volunteer by simply going to global5gevolution.com, and then you apply as a volunteer, and we have a form there for you to fill out. Very, very straightforward. Okay? And we'll provide you all the assistance you need for you to succeed using these platforms. Okay? And on the left here, we have all the skills I would love for you, would need, not love for you to have, but you can have just a few of these. You don't have to have everything. Right? And our team will make sure that if you're lacking in some fashion, we help you get that skill. Okay, so investors and entrepreneurs, students, entrepreneurs, you are the people with the ideas, but someone has to give life to them, so to say, right? And the investors are the people that will help you make that thing become a real application in the world. Right? So we're connecting you both with advisors as well as with investors. Okay? So it's a great opportunity because you will not just present like present and then you're done, but present and take it forward. And we're open to partner with you in that fashion. Okay, so Global 5G Evolution as an initiative, we have a lot of platforms, social media platforms. One of them is this YouTube channel, okay? This Global 5G Evolution YouTube channel, which we hope you can take. It looks like this, okay? So very simple for you to subscribe and stay in touch with everything 5G. Would love for you to join. There's a lot of free content that usually you have to pay for. As you can see, the people who invited today, as well as the people you see in these sessions, are experts in their field. There are people who have been doing this research for a long time. They know what they're talking about. And we're offering this knowledge for free because we think it's good if people can get this knowledge for free and allow them to build applications that benefit all of humanity. So that's all about Global 5G Evolution. And I'll share just one last thing, which is the website for students to see what template are we talking about. So that would be the last item for today. Okay, so when you go to Global 5G Evolution, this is the website, okay? And then all the details I've spoken about are here as well. But I'd like to draw your attention to the sample. Okay, so all the things I've talked about are here. Okay. Okay. So once you're ready, you've looked at all this and you're ready to go. We want you to structure your use case in somewhat this fashion, right? There is no rule per se, but this helps you organize yourself as well as helps us see your idea very clearly. So like, for example, for this one, we're just talking about what is the idea. In this case, it is cloud gaming. So what is cloud gaming? I spend a little time talking about what is cloud gaming. Then I spend a little time talking about the why of cloud gaming. In other words, two fronts. How does 5G enable cloud gaming? In other words, how does your solution you're saying is enabled by 5G? In what way is it being enabled by 5G? Right? You tell us about that. And then you also tell us about what exactly is it solving in society? What problem is it solving in society, right? Is it offering new ways of communicating? Is it offering new ways of doing what is it doing to society that we should be interested in? Because in the end, you need to sell it to people, right? And then who are the beneficiaries? Again, this is from an industrial point of view, which industries are benefiting or which individuals are benefiting. In other words, just pitch the why of your idea, okay? And then you tell us in truth, what are the challenges? If your solution hasn't been implemented, very likely there are a few challenges. We want you to tell us about those because the advisors, the experts we're inviting will be the ones to help you resolve those kinds of challenges, okay? And that's it. So this is on the website as well. Okay. So that's really it. This is the initiative. It is a global initiative, and we're hoping that we can have people from around the world bring in their most innovative ideas, okay? And that's it. Any other thoughts from the speakers here? Or from anyone here? Any questions or thoughts? Okay, and I've gotten a comment from Frank Meeven. Yes, I will place RWTH, Aachen University, on the list. Okay. Thank you. Okay, so speakers, I really appreciate your presentations today. We know that without you, we cannot help the student. So we are really grateful for the fact that you've taken time to share about what you know and how you see 5G evolving. And we're hoping that you can continue to work with us. We're looking forward to having these ideas come to you and you sharing your feedback to help these ideas come to life. So thank you very much. And that will be the end for today. Bye-bye.
Thank you. Thank you so much.
Thank you.
Thank you, Christian. Thank you, Tushan. Appreciate that. Thank you, Frank. Thank you, Nels. And Raj, I appreciate that.
Thank you.
Thank you.
Yeah.
Bye-bye.
Thank you, sir.
Bye.